Good morning, students. Today we'll do a new topic which is called common ion effect from the equilibrium chapter. So what is common ion effect? Actually this is one of the concept which is related with practical. When you do the practical, then you will get this idea what is common ion effect. First thing, I'll give you what is common ion effect. When two electrolytes are dissolved in a solvent and if both the electrolytes contain a common ion then the dissociation of weak electrolyte decreases. This is called common ion effect. So this is the definition of common ion effect. When two electrolytes are dissolved in a solvent, if both the electrolytes contain a common ion, then the dissociation of weak electrolyte decreases. This is called common ion effect. Now first thing, you should know what are electrolytes. Already I have told you, electrolyte means those substances which can produce ions in solution. They are called electrolyte. And you know there are two types of electrolyte. Some are called strong electrolyte and some are called weak electrolyte. Strong electrolyte means those electrolyte which undergo complete ionization, which undergo 100% ionization. They are called strong electrolyte. For example, strong acid, strong bases, salt, they act as strong electrolyte. Similarly, weak electrolyte means those electrolyte which do not undergo 100% ionization. They are partially ionized. For example, your weak acid, weak bases, they act as weak electrolyte. Now, what are common ion effect? Suppose this is a container and the container contain water. So this is simply water. In this water, when you dissolve acetic acid, the formula of acetic acid CH3COOH. So when you dissolve acetic acid in water, it produces two ions. One is CH3COO minus, which is called acetate ion, and one is H plus ion, which is called hydrogen ion. This type of substance which produce ions in water, they are called electrolyte. I mean acetic acid acts as electrolyte because it can produce ions. Now as you know, acetic acid is one of the weak acid, so that is why it will act as weak electrolyte. I mean these do not undergo complete ionization. Complete ionization means suppose you have dissolved 100 molecules of acetic acid. Among that 100, all the 100 molecules do not undergo dissociation like this. Little amount of molecule undergo dissociation. Maximum of molecule remain as undissociated because it is weak. But if you apply some strong, then it will completely ionize. Now, acetic acid we have dissolved in water. It contains two ions, acetate ion and hydrogen ion. Due to weak character, it will undergo partial ionization. Now in the same solvent, in the same water, if you apply another electrolyte, suppose CH3COONA, which is called sodium acetate. This sodium acetate acts as strong electrolyte. It is one example of salt. When you apply this strong electrolyte in the same solvent, it also undergo ionization, and which is 100% ionization, and it produces two ions. One is CH3COO minus and one will be Na plus ion. So acetic acid produce two ions, CH3CO minus and H plus. Sodium acetate will produce two ions, acetate ion and sodium ion. Now you have seen both the electrolyte contain a common ion. Which one ion is common? The CH3CO minus ion is common. So that you have written when two electrolytes are dissolved in a solvent and if both the electrolyte contain a common ion, then the dissociation of the weak electrolyte decreases. I mean, who is weak? Your acetic acid is the weak one. Acetic acid undergo little bit ionization, but after adding this sodium acetate, the dissociation capacity of acetic acid going on decreasing. Means initially it produces some acetate ion and hydrogen ion. After adding sodium acetate, the acetate ion again combine with hydrogen ion to produce the acetic acid. I mean, they undergo again combination. I mean, dissociation of this weak electrolyte going on decreasing, and this is called the common ion effect. And when after adding this strong electrolyte, when the dissociation of the weak one decreases, I mean when they undergo again combination of ions, then what happen? You will get the precipitate inside the solution, and which is called the common ion effect. So in some solution, when you dissolve something and when you mix something, you will get some precipitate. That precipitate, why the precipitate occur? This common ion effect is one of the factor to getting the precipitate. So when two electrolytes are dissolved in a common solvent and if both the electrolytes contain a common ion, then the dissociation capacity of this weak electrolyte going on decreasing, and you will get the precipitate in the solution. This effect is called common ion effect. Now, why the dissociation of weak one decreases after adding strong? As you know, acetic acid CH3COH, when you dissolve in water, since it is weak, it do not undergo 100% ionization, so it produces ions like this CH3COO minus, and this is acid, that's why it will release H plus ion, and that H plus ion combine with water to produce hydronium ion H3O plus ion. Here I have given H plus, but actually it produces hydronium ion as H3O plus ion. Because water is present, H plus ion always combine with H2O to produce hydronium ion. Any acid, when you dissolve in water, it produces hydronium ion instead of H plus ion. So when the acetic acid undergo ionization, since it is weak, it undergo partial ionization. I mean, all the molecules do not produce ions. So that is why inside the solution, you will get some dissociated ion and some undissociated molecule also. And due to presence of this ion and undissociated molecule, they will form an equilibrium which is called the Ionic Equilibrium. Now, if you want to write the dissociation constant of acid Ka, Ka means it will be multiplication of the concentration of product like this, divided by multiplication of the concentration of reactant, I mean concentration of CH3COOH. Already you have got this thing. Water concentration is remain constant, that's why no need to write water. So when you dissolve acetic acid in water, it produces two ions, and after production of ions, it will form equilibrium inside the solution which is called Ionic Equilibrium. And due to gaining the equilibrium state, you will get one dissociation constant of acid which is represented by Ka. So you will get a definite value of Ka for this acetic acid. If you know the concentration of acetate ion, hydronium and acetic acid concentration, when you put the value, then you will get the value of Ka. I mean, acetic acid have one particular Ka value in this solution. Now, when you dissolve another electrolyte like sodium acetate, then it also produces some ions, I mean acetate ion and sodium ion. Then when you dissolve this sodium acetate in the same solvent, then since it also produces acetate ion, so ultimately the concentration of acetate ion going on increasing in the solution. I mean, the amount of acetate ion increases in the solution. And due to increase in concentration of acetate ion, this one will going on increasing. Concentration of acetate ion going on increasing because the second electrolyte also have the acetate ion. When the concentration of acetate ion going on increasing, then the Ka value will be sense, because if this one sense, Ka also sense. But you know, for a particular acid, Ka is always constant, it do not sense. So if acetate ion sense, Ka will also sense. Now to keep the Ka value constant, because for a particular acid Ka is always constant, to keep the value of Ka constant, you have to increase the amount of acetic acid also. Then the value will remain same. And to increase the concentration of acetic acid, how will you increase? This acetate ion automatically combine with hydronium ion, they will form acetic acid to maintain the Ka value. And that is why after adding this strong electrolyte, these two ions again get combination to produce acetic acid. And that is why after adding strong, the dissociation capacity of the weak electrolyte going on decreasing. Initially it dissociate, but after adding strong, again the ions will combine to form acetic acid. And that is why after adding strong, the dissociation of the weak electrolyte decreases. And this effect is called common ion effect. Similarly, I can give you another example. Suppose this is water. In this water, you have dissolved one base which is ammonium hydroxide, which acts as electrolyte, and it produces two ions. One is NH4 plus ion and one is hydroxide ion, OH minus ion. You know this is a weak base, so that's why it undergo partial ionization. Now in the same solvent, if you apply another electrolyte like ammonium chloride, you know ammonium chloride is a salt, so it will act as strong. When you dissolve this ammonium chloride in water, it also produces two ions. One is NH4 plus and one is Cl minus. Now there is a common ion, NH4 plus. Due to this common ion from both the electrolyte, the dissociation capacity of ammonium hydroxide going on decreasing. I mean, this ammonium ion will combine with the OH minus ion to produce again NH4OH inside the solution. And that is why you will get the precipitate inside the solution, which is called common ion effect. The question will ask like this: the dissociation of NH4OH decreases in presence of NH4Cl. Why? So then you have to write the answer like this: it is due to common ion effect. Since ammonium hydroxide is weak electrolyte, so when we dissolve in water, it produces little ions like NH4 plus and OH minus ion. But after adding NH4Cl, it also produces NH4 plus and Cl minus ion. Due to presence of common ion NH4 plus, the concentration of ammonium ion increases, and to keep the value of Kb constant for base, you have to write Kb. To keep the value of Kb constant, NH4 ions will combine with OH minus ion to produce ammonium hydroxide, and that is why the dissociation capacity of NH4OH going on decreasing after adding NH4Cl. This effect is called common ion effect.